So today we're going to be factoring special products. We'll start with our perfect square trinomials. The pattern is a squared plus 2ab plus b squared. And so when we factor it, it's just going to be a plus b squared. So we're just going the opposite direction of what we did before. So what we mainly need to look at is the middle term. That's going to help us figure out whether or not it's a perfect square trinomial. So let's take a look at our first example. We've got 9x squared minus 15x plus 64. So I notice that 9x squared is a perfect square and 64 is a perfect square. So what's the square root of 9x squared? 3x. So I might have 3x times 3x. And what's the square root of 64? 8. So it could be 3x minus 8 and 3x minus 8. I know it's minus because of the negative sign here, right? So let me check the inside and the outside and see what happens. Here I get negative 24x, and I get another negative 24x. That adds up to negative 48x. Is that what I want in the middle? No. So since it doesn't work, it's not a perfect square. Does that make sense? So when you see that you've got a perfect square at the beginning and the end, you want to see if it is a perfect square altogether, and you test it out, okay? I've got another one for your notes right here. All right, so now I have 81x squared plus 90x plus 25. So again, I've got perfect squares on either end. So I'm going to see if 9x plus 5 times 9x plus 5. I'm going to check the inside and the outside and see if I get that 90x. So 5 times 9x gives me 45x. 9x times 5 also gives me 45x. That adds up to 90x. So is it a perfect square? Yes, it is. That's what we want. And so if I factor it, then I can just write it 9x plus 5 squared. Okay? Any questions? All right, so I'm going to have you guys do this one on your whiteboards. Okay, so when you guys tested it, x plus 2 times x plus 2, it worked, right? So you rewrite it with just the one parenthesis squared, okay? So yeah, that one was yes, and it's x plus 2. Alrighty, let me... Okay, this is for your whiteboards also. So same thing, I want to know, is it a perfect square? And if so, factor it. Okay, so we see if it's 3x minus 2 times 3x minus 2. If you check the inside and the outside, we get negative 6x, negative 6x. Is that going to add up to negative 6x? No, it adds up to negative 12. So no, that one is not. Okay, this is for your notes. Okay, now, right off the bat, if I look at my first and my last, the first one's a perfect square.
Bless you.
What about this term here? Is 14 a perfect square? No, 14 is not a perfect square. So there's no way that it can be a perfect square. I don't even have to try the inside and the outside because I know that 14 is not a perfect square. Okay? So I don't even have to do anything else. That's it. I'm done. All right? So that's more for you to practice on. So this one's for your whiteboards. They're kind of hidden back there behind the trophies, next to that plastic bag. Yes, that's right. Yes, that's it. Okay, so for 9x squared, we have 3x, and for 9, we have 3. How do I know if it's a plus or minus sign? Looking at that middle term, it's negative, so this has to be negative. So if we do 3x minus 3 times 3x minus 3, we get negative 9x, negative 9x. Sure enough, it works. And so we have 3x minus 3 squared. Okay. Do you guys need to practice another one of those, or you're okay? All right. Let's take a look at the difference of squares then. All right, so difference of squares. When you hear the word difference, that means we're doing what? Subtraction. And by squares, I mean your perfect squares. So 1 squared, which is 1. What's 2 squared? 2 times 2 is? 3 times 3? 4 times 4? Next. Keep going. Keep going. Okay. How about 121? That's 11 squared. What's 12 squared? 144. 13 squared? 169. Good job. 14 squared? 196. How about 15 squared? 225. Yeah. Okay, so you should know up to 15 squared just so that you recognize it when you see it. And then also, of course, x squared is a perfect square, right? What about x to the 4th? Yeah. X to the 6th. X to the 8th. Any even exponent. Okay? All right, so that's what we're looking for. We're looking for subtraction problems with 2 perfect squares. And so if I have, for example here, x squared minus 81, and then just a reminder from before, and we talked about this while we were doing our 5-a-days, if I have a sum and difference pattern, that means I've got a plus b times a minus b, right? And that's when we ended up getting the difference of squares, a squared minus b squared. So now that's what we've got here, right? A squared minus b squared. So we're just going to go the other direction. If I have the difference of squares, that means I have different signs. Okay? I say difference of squares, you say? One person said it. I say difference of squares, you say? Different signs. Okay. So here, the square root of x squared is x. So I know that the first term is x. And what's the square root of 81? 9. And I have to have different signs in order for them to cancel out. Because here I get a positive 9x, here I get a negative 9x, that equals 0, and that's how I end up with just the x squared minus 81, because those two middle terms cancel each other out. Okay? So whenever you have an a squared minus b squared, you know it's a plus b times a minus b. We're just going the opposite direction. We used to start with the sum and difference pattern. Now we're starting here, and when we factor it, that's our answer, okay? All right, so let's do one on whiteboards for you. Oops. All right, do that one on your whiteboards. All right, so we have the difference of squares. What's the square root of 225? 15. So they're both going to have x and 15. But because it's the different squares, I have different signs. One's a plus, one's a minus. Practice. Or here's another, oh, I didn't clear that page off. Yikes. Okay, there we go. All right, here's another example. All right, so now I've got 9x to the 4th and 16y squared. Are those still perfect squares? Yeah, they are. What's the square root of my 9x to the 4th? 3x squared, right. So I'm going to have 3x squared times 3x squared to get my 9x to the 4th. And what do I have to multiply to get 16y squared? 4y. And because it's the difference of squares, I have different signs. Okay, questions there? All right, on your whiteboards. (121) y to the 6th minus 25x squared. All right, difference of squares, what's that mean? Different signs, one's a plus, one's a minus. What's the square root of 121 y to the 6th? 11 y to what power? Cubed, yes. And so that's going to be in front. And then what's the square root of 25x squared? 5x. All right, now sometimes you're going to get problems that look like this. And I look at it and I'm like, okay, 50 is not a perfect square. 18 is not a perfect square. But it kind of looks like the difference of squares, but not quite, right? So what you want to do in that case is ask yourself, is there a greatest common factor that I can factor out? So is there a number that goes into 50 and goes into 18? What is it? 2, right? So I'm going to factor out that greatest common factor first. I'm going to take out the 2, and then I'm left with 25x squared minus 9. Do I have perfect squares now? Yes, I do. So I still have the 2. I can't just throw it away. It's still out there. And then what's the square root of 25x squared? 5x. And the square root of 9? 3. And I have what? Different signs. Yeah. Okay? Any questions there? All right, let's have you guys do one of those on your whiteboards. So, how about 75x to the 4th minus 48y squared? See if you can find a GCF in there to take out first. All right, so when you factored out the 3, you got 25x to the 4th minus 16y squared. So if we take the square root of 25x to the 4th, we get 5x squared. And we get 4y for the 16y squared. One's plus, one's minus. All right, got one more for you guys. All right, give that one a try. All right, so you factored out the 2 and got 49x squared minus 4, and then you factor that into 2 times 7x plus 2 and 7x minus 2. All right, that's all I've got for you guys today.